All right.
Okay, so just like the last problem, we're pretty much working with x squared. So the function is actually piecewise, and it says that f of x is equal to x squared when x is not equal to 2. And when x is equal to 2, the y value is 3. So looking at this graph right here, the graph of x squared, you can see that where x is equal to 2, it needs to be equal to 3. So what we do is actually put a whole circle right there, and then we plot at x equals 2, the dot right here. And as you can see, it's right below it. It's at where x is equal to 2, but the y value is 3. So what we would call this actually is non-continuous or discontinuous. It doesn't have continuity. So in this case, we're actually finding the limit. So the limit as x approaches 2 of our function, which in this case is f of x. Alright, so just like in the previous example, we're going to come from the left and come from the right from the larger x values and see what it approaches. As we come from the left at 1.999, it's approaching 4. And at 2.0001, it's also approaching 4. So, in this case, the limit actually still is equal to 4, because that is what they are approaching from both sides. Although f of x, or f of 2, is equal to 3. So in this case, the limit as x approaches 2 of f of x is equal to 4, which is not equal to f of 2.
Alright.
Okay, so this next example is also a piecewise function. In this case, we're working with x squared and x plus 1. So in the previous example, it had been x squared pretty much all the way through. So the domain of this problem, where we're using x squared, is when x is less than 0. So for all values less than 0, it's going to look like the x squared graph. And as you see, there's a circle here because on this, there is no equals to. So it's just x is less than 0. Now, if you're working with a positive x value, you're looking at x plus 1, which is a straight line, or which is a sloped line that runs from x is equal to 0 and 1 from the y coordinate and up. And as you see, there's a point here, a close point, because we said while x is greater than or equal to 0. So this is the graph of the work. And what we want to find is the limit as x approaches 0 of our function. Okay? So once again, to find this like we did in the other problems.
Alright.
So there's a way to write this. So first we're going to come from the left side. And we're going to come down like this, following the curve. Okay? So when you write it coming from the negative side, as we're approaching the point, the limit as x approaches 0 from the negative side of f of x. Okay? In this case, as we can see, as it approaches 0, the y value is approaching 0. So in this case, it's equal to 0. The limit as x approaches 0 from the positive side of f of x is going to be working with this linear function coming down this way. And as you can see, this one is approaching 1. So as it's coming down, it's approaching 1. So the limit of this overall function as x approaches 0 is going to be, does not exist. And this is because the values of the left side and the right side have to be the same in order for the limit to exist. In this case, they're different. It doesn't matter that the actual value at this point is 1 or anything like that. What's important is the fact that they do not match up. The limit coming from this side is 0, the limit coming from this side is 1. So the limit as x approaches 0 of this problem doesn't exist.